So we're going to look a little bit more into scatter plots today. So we did a little bit of that yesterday. They have to be for two variable data. So you need to be tracking something versus something else that's actually, we talked about attributes yesterday. So it has to have two attributes, which means it's like measurable data, right? So rather than like names of something and then like a specific thing that you're tracking, it needs to have two specific things. So we would call that the dependent variable and the independent variable. I gave you the example yesterday of, let's say, distance and time. So if you're taking a trip, does the distance depend on the time that it is, or does the time depend on the distance, right? So thinking about which one is independent and which one is dependent. Usually time is independent, and then you'll have some kind of other dependent variable, like it could be speed or distance. So based on the time, then I can figure out, oh, what was the distance at that particular time or something like that. Or another example that the lesson gives us here is the value of the car depending on age, which again is time, right? So at 10 years, what is the new value of that car? Or at 13 years, what's the new value of that car? So the independent variable is always going to be plotted on the x-axis, and the dependent will always be plotted on the y-axis or the vertical axis. All right, so let's look at an example here. So we have Jay researching estimates for a job painting his house. The scatter plot shows his results. Which would be the dependent variable here? So remember, independent is on the horizontal and dependent is on the vertical. So I'm asking what's the dependent? Okay, so the cost is going to be dependent on the time required to complete the project, right? That makes sense. Like if you have a 2-day project, that's obviously going to be a lower cost versus like if somebody thinks it's going to take them a week to do that project, that's going to be a higher cost. Okay, so the cost is dependent on the amount of time the project will take. Okay. Which two companies will take the longest? And out of those, which is cheaper? So which two companies are taking the longest to paint the house? D and E, because they're highest on the time required. And which one is cheaper? Looks like they're both spending the same amount of time. Which one has the lower cost? Okay. Perfect. Which two companies charge the same amount? B and D. Perfect. Okay, so we can see along the cost line here, B and D are basically charging the same amount. However, one takes less time and one takes more time. Why might you pick company E? Yep. So although it takes the longest, it's also the lowest cost. So company E, you might choose, like maybe if you don't have a timeline that you want that project completed in, so maybe you don't care that it takes them longer, and they have the lower cost. How about company B? Why might you choose company B? Yeah, if we look at kind of how long those are taking, it's only a step up from company E, but half the time. I'll say about half the amount of time as companies E and D. All right, let's go to the next side here. All right, so yesterday we also discussed in our unit terms what a correlation is. So that's basically the relationship between your independent variable and your dependent variable when you're graphing two variable data on a scatter plot. So it might show a correlation between the variables, meaning we can see a strong trend in how those variables are correlated together. So for instance, the graph number 1 here displays what we would call a positive correlation. So both variables are increasing together. So you'll see something that almost looks like if you were to draw a line, it's like a line with a positive slope that goes up toward the right. So the points are each going up, like as this one goes up, this one also goes up. Negative correlation, we can see in the second graph here. If we were to kind of draw a line through that data, we can see that it's like a line with a negative slope. So as one increases, the other one decreases. So you're going to see that the points go down toward the right for a negative correlation. All right, so let's analyze some data here using a scatter plot. So we have a situation. Davis conducted an experiment comparing a person's leg length to how long it takes that person to walk 100 meters. He gathered the data below, showing leg length in centimeters and time taken in seconds. So our x-coordinate is the leg length, our y-coordinate is time taken in seconds to walk 100 meters. So we're going to graph the data. What might you expect to see from this data if you're thinking about, like, if I have longer legs, what's the time, what's the impact on the time it might take you to walk 100 meters? Okay, so the guess would be that longer leg length leads to shorter time to walk 100 meters. Okay, so we're going to start by labeling both of our axes here. So let's do that and that. And we're going to label what we're measuring for the independent variable and what we're measuring for the dependent. So this is going to be, it said x was the leg length in centimeters. So we'll put cm brackets underneath there. And then the time taken in seconds. So time to walk 100 meters, and that is measured in seconds. All right, so if we look at some of our data points here for the x coordinates, we have things between basically like 54, and then the highest that we need to get up to is about 83. So I'm thinking what we might do is kind of do like what I showed you how to do in some previous units, which is like we kind of squish the x-axis like this, and then we'll start kind of toward some of the larger parts of data, because I don't really need any of the numbers from like 1 to 50, right? So from there, maybe we can go by like 2s or something like that. So let's say we call this 50, because we squished all that part of the graph. So it basically just means we're squishing 1 to 50 all together because we don't need it. And then maybe we can do 52, 54, 56, 58, and then 60. So every 5 ticks is going to be 10, basically. 62, 64, 66, 68, 70, 2, 4, 6, 8, 80. And if you want, you can label like in between there as well. And then 82, 84, 86, 88, 90. Okay, and because of the y coordinates here, looks like the y coordinates or the time that it takes to walk 100 meters, the lowest one that we have is 62, and then the highest, what do you see the highest? 83. Do you see any that are higher? I think 83 is the highest. So we'll do something similar. We'll squish this part of the graph as well, and then we'll start labeling from there. Maybe I'll just make that a little smaller. So we'll do that. And then let's start at maybe 60 here. And we'll go by twos again. I think that will allow us to fit everything well. 62, 64, 66, 68, 70, 2, 4, 6, 8, 80, 2, 4, 6, 8, 90. Okay, and then we'll start graphing the points here. So 80 and 66. 73 and 74. 60 and 83. 64, 62. And so on. Oh, one needs to go up one. Just check the points off as you go. Make sure you get all of them. 78, 76. Oh, I just realized I was right with that one before. That one can go down one. It should be right there. 63, 75, 2, 4, 5. Yeah. Okay, 83, 64. 54, 81. 73, 70. Oh, did I plot this one wrong? Oh yeah, this one should be, oh no, 73, 70. Do I have another one at 73? I do. 78, 76. Oh, and we have two of those, so that point is already plotted. All right, looks like you've got basically the same as me. This one is maybe higher. Mine is up at, that one is 81, and then this one's 83. So 60 should be up at 83, which is here. Okay, perfect. So does the graph suggest a relationship between leg length and time taken to walk 100 meters? If so, describe the relationship. Mm-hmm. Yeah, okay, so we can kind of see like a bit of a negative correlation here. There's one small outlier over here, but in general, we can kind of see that as leg length increases, the time taken to walk 100 meters goes down. We can say since points trend down toward the right, it suggests that what we call the negative correlation. Meaning as leg length increases, time taken to walk 100 meters decreases. Okay, so one is increasing and one is decreasing. That means negative correlation. Perfect. Use the scatter plot to estimate the time it would take a person with leg length 85 to walk 100 meters. Explain. Okay, so going back up to the graph here, I kind of created a bit of a line of best fit here. So normally we would do that with a ruler. So I'm going to just kind of go over this line that I created here. That kind of equally separates some of the data points, and I'm going to use that line to do an estimate here. So at 85, which is like right here, we're just going to kind of estimate using this line approximately how long it might take them. So that's our estimate point. And that is happening at 65, approximately 65 seconds. Okay, so you're going to kind of create a line of best fit. It might go down a little bit further. Like sometimes you might place your line, let's say, maybe more something like this, kind of along some of these points here. So obviously, like however you draw your line is going to impact some of that. This might be a little bit more accurate because obviously someone that has an even longer leg length than these two might take a tiny bit shorter. So maybe a better estimate might be something like 63 instead of 65. Okay, so we can say using the downward trend, if we draw a line, we can see it would take someone with leg length, or let's just say someone with legs that are 85 centimeters, about 63 seconds to walk 100 meters. Okay, because we observed that the point was 85, 63, or maybe 65 seconds, we don't know. All right, and then the last question here is, how might Davis make the results of his experiment more reliable? So anytime you have like a sample set of data, the larger that sample set is, the more accurate your data is going to be. So if I've only looked at 10 people and how far they can walk with that particular leg length, that's not as good as if I look at 20 people or 100 people, right? So getting more data from more people always makes the experiment more reliable. Okay, so if Davis gathers more data from more people, he increases his sample set, which typically provides better, more reliable data. So if people are doing studies, like there's a lot of universities that will do studies, or like Statistics Canada does like a whole bunch of studies on like the population and all of like they do a whole bunch of stuff that they get from like census information. So it's just like people will fill out the census like voluntarily. Obviously, if I'm at a university doing a study, I don't want to just track 10 people, right? I want to track like maybe 1,000 people or even more than that. And that's going to give me better data. So one important thing is that observing a relationship between two variables, for instance, like leg length and how long it takes you to walk 100 meters, doesn't necessarily mean that correlation means causation. So it doesn't necessarily mean that the leg length is going to cause you to walk faster. So that's always like a difficult thing in statistics that people have to look at carefully, right? Because you'll hear people say like, oh, correlation doesn't equal causation, and that's because like you could observe two things, but like to actually be able to connect them um, and prove that conclusively is actually very difficult to do. Now, of course, leg length and walking 100 meters, that's a little bit easier for somebody to say like, well, obviously, if your legs are a little bit longer, you might have a longer stride and all of that kind of stuff. But when things get more complex, it's much harder to do. All right, so considering possible cause and effect, we're gonna go over whether each of these claims in each of the situations feel reasonable or not. All right, so we have a scientific study showed negative correlation between aerobic exercise and blood pressure. It claimed that the increase in aerobic activity was the cause of decrease in blood pressure. Do we think that is reasonable? That if you are active, that your blood pressure goes down? Or do we think that that is unreasonable? I don't think it's necessarily like as they're doing the exercise. I think it's just like taking your blood pressure at like any time in the day kind of thing. So usually like like having very low blood pressure and like that means that like your blood is not circulating as much as it should be. And then having high blood pressure can be caused by things like being overweight, eating improperly, a whole bunch of different factors, right? So if you have what we would call like normal blood pressure, that's kind of where you want to be. But if somebody had high blood pressure, then obviously they want to decrease their blood pressure. So exercise can do that for you. So I would say it can be somewhat reasonable, although like you don't want to have like super, super low blood pressure. Like if somebody had really low blood pressure, we wouldn't say that that's necessarily caused by their aerobic activity because they are like obviously raising their blood pressure and like raising, well, we would say raising their heart rate, right, as they exercise. So reasonable, although many factors are going to affect that, like their eating, their sleep, all of those kind of things impact your blood pressure. Okay, so this one would be like reasonable. Obviously, you'd have to know a little bit about like what causes your blood pressure to go up and down. I don't think we could say that it's like 100% the aerobic activity. So we'd have to say there are many factors that could impact somebody's blood pressure. For instance, like I'm pregnant right now, and that actually like once you get into the middle of your pregnancy, that can lower your blood pressure because like your blood is obviously like going to your baby and like different things like that. So there's lots of different factors that can impact blood pressure. Okay, just as an example, diet can do those things. And obviously, you can do all the aerobic activity that you want, but if you have a bad diet, that's still going to impact it. So diet, we could also just say like sleep, stress, all of those things. All right, Mila discovered a positive correlation between gasoline price and average monthly temperature. She concluded that temperature determines the price of gasoline. Reasonable or unreasonable? Yeah. Okay. Why? So reasonable or not reasonable? You still stand by not reasonable? Mm-hmm. Mm-hmm. Okay. Not reasonable, although like maybe people travel a little bit more in the summer. That might impact gas prices, but in general, just because the temperature is high or low doesn't mean the gas will be more or less expensive. Um, so we'll say people might travel more in warmer seasons, but this does not always mean that the gas will go up. As we can see right now, obviously, like some of the gas prices went up with like all the war and all of that stuff that's going on in Iran and all of that, all of those kinds of factors. So there's lots of political factors at play as well. Since the 1950s, the concentration of carbon dioxide in the atmosphere has been increasing. Crime rates in many countries have also increased over this time period. Does more carbon dioxide in the atmosphere cause people to commit crimes? Reasonable or unreasonable?
I think carbon dioxide
Okay, so unreasonable.
Yeah.
Okay, so we'll say unreasonable. Maybe more likely is that the population in the world has increased. Therefore, if there's more people, there's probably more crimes being committed, right? Versus like the carbon dioxide. There's also more people breathing in oxygen and releasing carbon dioxide. So that's kind of correlated in some way, but it doesn't mean that those people all commit crimes, right? So more people might mean more carbon dioxide. More people might also mean more crime. But those two are not directly related necessarily. Okay, so these would be like probable conclusions, but not necessarily like reasonable to connect the two because of that. Okay, perfect. So that's our lesson. So we'll go through some homework questions.